Hey guys, how's it going? So in this tutorial, I'm gonna show you guys how to calculate FWHM for the various peaks in your XRD pattern. Now the FWHM is given by a formula, something like this. This is called the Scherrer formula. So here, beta is your full width at half maxima, and it is directly proportional to 2 theta or dependent on that. Then it is equal to k lambda by L cos theta, where L is the crystallite size. Therefore, the peak width is needed to calculate the crystallite size for your sample, and that is what I'm going to show you how to do that. And the factor k here is, it can take several values depending on the type or the shape and size of your sample. So it can either take 0.89, 0.94, and many people just take it to be 1. It doesn't really matter that much. Then lambda is the wavelength of your X-ray, and cos theta, here theta would be the angle or the position, angular position of the peak, and beta, that is the full width at half maxima, or the FWHM, should be in radians. So many people make the mistake, even I used to do that, or did that one time at least, that I took beta in degrees. So you have to take that in radians. And another way to calculate the crystallite size could be to use the integral breadth instead of FWHM, and that can also be done pretty easily, but I will show that in some other video, and this video will be dedicated to only learning how to calculate the FWHM. So how to calculate the FWHM would be to use some kind of software that performs a Gaussian fit for my XRD pattern, and in my case I'll be using Origin. And so you should, if you don't have Origin, then you should get Origin, or maybe watch some other tutorial, because this one is based on Origin. So another thing to know is that I'm not sure about that, but I don't think that Origin version less than 8 or 8.5 can do this. I have got Origin 9, but just make sure that you get some latest Origin to do this, because I'm not sure if versions before 8.5 could do that. I mean, they do have wizard that performs a fit, but I'm not really sure how well that is. Okay, so enough with the chit chat, and now let's begin to calculate the FWHM for my XRD pattern. So I have my XRD data in this notepad file or txt file. So let me just copy all that, and okay, so let's copy all the data, and now we will plot it. Oh, whoops, gonna have to repeat that again. Okay, so just copy all the data down till the very end, press Ctrl C and paste it in the Excel window. Okay, so now I have the data. Okay, so just what I did was I pressed Ctrl and selected the two columns and right clicked on them, then went to plot and went to line, then line. So that will plot your XRD pattern. Okay, so here is the XRD pattern. As you can see, I have a ready-made theme that shows 2 theta here, intensity here, and you can just label whatever you want here. Okay, so let's say I want to get the FWHM for this particular peak right here. This is the highest intensity peaks, and it should be noted that to get the crystallite size, it is advised to get the width of the most intense peaks of your XRD pattern. So just press here to scale into this peak. Okay, and make sure you have some of the background radiation on the both sides, and then go to analysis, then to peaks and baselines, then multiple peak fit, and open the dialog. Okay, so in this dialog what you need to do is you need to select a peak function, and I'll be using a Gaussian function. Okay, now it will prompt you to double click to pick the peaks. In my case it's just one, so I'll just go ahead and here I'll double click it, and then open nLift. That stands for nonlinear fit. Okay, so here it is, showing you various parameters like base, center, amplitude, FWHM, etc. Now what you need to do is you need to click here, that is fit until converged, and voila, your Gaussian fit is ready, and you can get the parameters from here. That is, the FWHM for this particular fit is 0.19842. okay, then, and this dialog box also shows you the kind of function that you are using to fit your data, and you can use many of the functions by just going to settings and picking up some other functions and fitting your data. So anywho, what we needed was FWHM using the Gaussian fit, and we got it. So just go ahead and press done, and it will generate a good nice table for you. So this is some statistical data like the R-square values, etc., and a lot of data is here, and you can just check the fitted points also here. Then I don't need that. All I need is the plot right here. So I have got that. So here I have my equation of the Gaussian fit, the R reduced chi-square value, the adjusted R-square, etc., and all the parameters for the fit. Okay, so that's how you calculate the Gaussian fit for a particular peak. And in case you wanted to do a lot of peaks at once, then what you could have done was just okay, so to illustrate that, let me just create another graph. So I'll just go to this book back, sheet 1, and let me just create another graph to show you how to get the Gaussian fit for a number of peaks at once. So what you need to do is basically just go ahead and select multiple peaks, and then go to analysis, multiple peak fit. That is what we used last time. Okay, so Gaussian. Okay, select the peaks by double clicking on those. Open nLift, nonlinear fit. Okay, and then just fit them until they converge. Okay, now as you can see, the iterations keep on going and going, and they will probably go until 100, but I'll just go ahead and stop it right now. So what you can see is that even after so many iterations, it just couldn't provide a fit for this third peak. So maybe we should select the peaks a little differently. So maybe we can get these two peaks at once, but not the third peak along with them. So that is a common problem. So it is usually advised to only take the most intense peaks for your for the analysis of crystallite size. And as you could see, that peak, the third peak, was pretty much relatively really small compared to these two, so there was some problem with that. And here what I've done is I just pressed this, and I got the Gaussian fit for the two peaks at once, and we can see that it is pretty good actually. The blue curve, if you see, it is pretty much same, or it is approximating the original data pretty good. So the two FWHM for the two peaks are 0.199 and 0.21. Okay, so well, that's it. That's how you perform a Gaussian fit for your peaks in your XRD data and get the FWHM, and thus calculate the crystallite size using the formula that I just mentioned. Okay, well, hope you enjoyed this video and learned something from it, and if you did, don't forget to hit the like button and subscribe to my channel for more videos like this. And thanks for watching, and have a great day.